Welcome everyone. I'm so glad that you're here today. We've got a presentation with some information about keeping litter dry and probably more importantly, just trying to avoid wet litter or trying to keep the litter more uniformly dry throughout the entire shed. We've just finished a research project where we've been looking at litter drying again, litter modelling. There's quite a bit going on. So I've tried to include some of that in today's presentation. First of all, just want to acknowledge the people who have supported all this research and continue to, which is AgriFutures and the Department of Agriculture and Fisheries in Queensland. And thanks always to the growers who contribute to this research, either with information that they share with us, the methods that they share with us, like when we did our industry survey or when people just talk to us and let us know how they go about doing things. And then of course, for the farmers who let us do our work on their farms, it's always greatly appreciated. So there's no new sort of information here. What is required to keep litter dry and to avoid wet litter? It's about reducing the amount of water going onto the litter and then maximising the amount of evaporation. So in today's presentation, I'm going to talk about both of these things, about trying to reduce the amount of water, especially from the drinkers, but then also talk about how we can try and maximise the amount of evaporation. So trying to get the water back out of the litter and get it out of the shed. As always, there's no silver bullet. You will know better than I do that trying to keep litter conditions the way, dry and friable state and avoiding wet litter and caked litter requires managing all aspects of growing chickens. So it's the drinkers, ventilation, setting the shed up before the flock, managing your chickens, hopefully having good, healthy chickens, preheating the shed before the start, heating it when the birds are there. All of these things are important for trying to manage the litter conditions and keep on top of them. We've worked out years ago, or everyone sort of knows, the chickens are the main source of water going onto the floor. At the peak of the flock, sort of before the first thin out, there's about 2 litres of water per square metre going onto the floor every day. In most of the bigger sheds these days, that means there's sort of 5,000 to 6,000 litres of water that are going onto the floor that needs to be ventilated out of the shed every single day. At the end of breeding, it's about half that. So you've still got to get 2,500 litres of water or thereabouts out of the floor and out of the shed every single day. So it's about trying to keep on top of it and about trying to maximise the evaporation that you can get within that day sort of period. You've got to get the water out every single day that goes onto the litter. Starting with the drinkers, this is one area where, of course, the wet litter tends to start. Under the drinkers is always a priority area. Drinkers can both leak water, but as the chickens drink from them, they spill water as well. Trying to correct those things sort of requires adjusting the height and pressure of the drinkers regularly, but it's important to fix leaks, replace or fix damaged drinkers, clean and sanitize and flush the drinker lines regularly, have good water quality because that affects the drinkers and their performance and how long they last. And if all of those things don't work, then maybe it's worthwhile considering changing to medium flow drinkers. Talking about some of these things in a little bit more detail, the drinker flow rate that the birds need, of course, changes as they grow. So with little birds, they only need a little bit of water. Over the course of the flock, you probably know that you change the pressure in sort of 2 to 4 main sort of steps. But the height of the drinkers needs to be adjusted far more often, every day. Some growers have said that at times that they tweak the height of the drinkers a couple of times a day. Most of the time when we're trying to manage the drinker flow rate, you base it on the height of the water that's in the sight tubes. because it's that pressure that changes the flow rate in the drink nipples. Every now and then it's worthwhile measuring that flow rate, because over time, the amount of water going through the drinker nipples can change, and it may be a reason why there might be wetter litter forming underneath the drinkers. Ways to do this have been sort of known for a fair while. There's methods in both the Cobb and the Ross manuals, or from the breed companies, about how you can go about measuring the water flow rate in your drinker nipples. We've got a little bit of a diagram here. So you catch a bit of water for a certain amount of time so that you can work out the amount of flow rate per minute. And then you can use that to compare to the requirements for your birds. The table on this slide shows the recommended flow rates. So at the start of the flock, you're looking at sort of 20 to 40 millilitres per minute, which is a fairly low amount of water, up to a maximum of, it says about 100 mils per minute. For Cobb, they've sort of wound that back a little bit, and it's only about 90. These numbers might be a bit different to the ones that you're currently working with. But if you're finding that your litter is consistently getting wet under the drinkers, it might be worth measuring the flow rate of your drinkers and consider winding it back to match these values for a little bit and see how the litter responds. And then also, of course, monitor your the growth rate of your birds and make sure that you're not impacting their performance or their growth. So what we're talking about is adjusting the drinkers based on the litter conditions. Other people have sort of recommended this as well. One of the challenges with it is that it can take a couple of days to be able to see the difference. After you wind the drinkers back a little bit, it might take a few days for them to dry out. If you turn the pressure up a little bit, it might take a few days for it to start to show in the litter. A grower down in South Australia gave us this suggestion to try putting a bit of brooding paper underneath the drinkers, leave it for 10 or 15 minutes and look at how much water is on it and how much it spreads around. When this grower did this, they found that there was water just spraying everywhere, basically, is the way they've described it. So they made some changes and then retested it, and they found there was a lot less litter coming out of the drinkers and onto the floor. And they've, since making that change, their litter is a lot drier, and they said the bird performance hasn't changed at all. So this is a much quicker test. Instead of waiting days to make that decision, you can make the decisions a little bit quicker. Drinkers don't last forever. At best, they're going to last 5 to 10 years, but it can be a lot shorter than that, depending on your water quality, the cleaning chemicals you use, and if they get damaged, just in through normal use. If you are going to replace drinkers, have a think about using medium flow drinkers. There are more growers adopting these things, and what they tell us is that after using them, the litter's a lot drier. They have a lot less issues with caking. And most of them have said that the performance of the birds hasn't changed. So with your standard high flow drinkers, one thing that growers have told us is that there's not a lot of difference in pressure between for very little birds and then maximum flow rate. So you don't get a lot of resolution. A small amount of increase too much is too much water. With medium flow drinkers, you need to use more pressure to get the same flow rate. And so the benefit of having medium flow drinkers is that you can actually control the drinker flow rate a lot better, particularly at the with smaller birds and at the start of the batch. And there's a lot less chance of there being excess water that's going to end up on the floor. Now onto evaporation, and this is where I kind of know a lot more than trying to manage drinkers. If the litter is wet all the way through, once that surface dries, it then becomes a barrier to water coming out of the litter. So if you've got to try and remove that 2,000 to 6,000 litres of water every day within that day period, you really need to get the most amount of water out of that litter, when you need to get it out during the day. One thing that you can do to try and bring water that's deep in the litter up to the surface is to do tilling. And what that does is it actually sort of brings the damp litter to the surface where it can, when that water can then be evaporated out into the shed and then taken out of the shed. When I talk about evaporation time, one thing that we've learned through doing some modelling of evaporation rates in litter is that the most of the evaporation happens between about 9 a.m. and 6 p.m. That'll change a little bit with seasons, no doubt, but between 9 a.m. and 6 p.m. So outside of those times, the litter is a sponge. It's going to get wetter during the evening. It needs to absorb any water that the birds or the drinkers are putting onto the litter. But then between 9 and 6 p.m, you've got to try and get all of that water out of the shed. And that's where it's important to try and take steps that are going to maximise the amount of evaporation, but especially between that 9 a.m. and 6 p.m. period of the day. Just a few more points on tilling. Tilling doesn't just break up cake and to make the litter friable again, it also increases the evaporation rate. It does this by opening up the litter and increasing the surface area of the particles within the litter. Through some experiments, and I've shown you these figures before, with cake litter, by tilling the litter, you're going to increase the evaporation rate by about 12 to 15 times, but that only lasts for about 4 to 6 hours. After that, the rate of evaporation decreases, and it might be 7 times higher than it was when it was just cake litter. Up to about 15 hours, and then that continues to reduce. Compared to friable litter, cake litter is always going to have only about a third of the evaporation rate as friable litter. So that's where, when we say dry and friable, there's a benefit for the birds with friable litter, generally speaking. But from a litter management point of view and a perspective of trying to get the litter drier, having friable litter actually helps you to evaporate more water and keep the litter drier. But even with friable litter, tilling the litter increases the evaporation rate. So after you till the litter, you'll have higher evaporation rate. It'll be 4 or 5 times higher for the first 4 or 6 hours. Then it reduces to about 2 to 2.5 times for 12 to 15 hours after tilling. After 24 hours, it seems to return back to about normal. So where I was saying before is that you've got a very narrow window of time when you really can evaporate water out of the litter. If you're going to till the litter, try and target to the time sort of in the mid to late morning, so that you've got the whole afternoon where you've got the warm, usually drier air to try and get as much water out of the shed as you can. Because once you get back into the evening, evaporation is going to slow down anyway, and then you're just going to start absorbing water into the litter again. After tilling, if you can keep it friable, the chickens keep working it for you and keep mixing it up, and they're digging and exposing new litter brings more moisture to the surface where it can be evaporated. So the chickens are actually helping you to dry the litter out faster. One of the essential things to evaporate water is heat. Heat's produced by both the birds and the heaters, but it's what we do with the heat that's really important, and there are a few things that we can do to try and use it for our benefit. First of all, adding heat to air reduces the relative humidity of the air. So there's a rule of thumb that if you increase the air temperature by 10 degrees, you reduce the relative humidity by about half. So if you can increase the air temperature in the shed compared to outside, you will actually reduce the relative humidity. But one thing that's important to understand is that it's more important to heat the floor and the litter than just blow hot air over the top of it. If your floor's cold, evaporation rate will be greatly reduced. So taking steps to preheat the shed and get heat energy stored in the floor and in the litter will help you for a much longer period of time in the batch to keep the litter dry. To absorb the water that's coming out of the litter into the air needs to be able to hold it. So having low relative humidity is essential. Aiming for 50 to 60% relative humidity in the shed is considered ideal from a litter drying perspective. Growers ask me, how do you do this, especially if it's humid outside? First of all, trying to start with dry litter and keeping it dry for as long as you can and as dry as you can will help to keep the relative humidity in the shed down. If the litter gets wet, the humidity in the shed will go up and then it gets harder and harder to actually dry the litter. So starting with dry litter and keeping it dry is essential. Ventilating water out of the shed is also essential. As we said right at the start, there's 2,500 to 6,000 litres of water that needs to be ventilated out of the shed every single day. So even if you take other steps like the tilling, and we'll talk about a few other practices that you can do that get more water out of the floor, you've still got to ventilate it out of the shed. So you need to have enough ventilation to get the moisture out of the shed. As a general rule, if relative humidity is high, you've got to increase the ventilation rate and add more heat or add more heat. It just depends on which stage of the batch you're at. One way that you can counteract high relative humidity, so if you're in an area where you struggle to actually get lower relative humidity in the shed, is to increase the amount of airspeed and air movement within the shed. So I'm going to talk about that in a few slides later. All of your sheds are set up for side ventilation mode, or most of your sheds will be set up for this. It's the most common, shed building design in Australia for chickens. And this is designed to get the water out of the litter and dry the litter. So the idea is to get the cool air coming in from outside, heat it with heat energy that's stored up in the ceiling because heat rises. And as it comes down, it reduces the relative humidity of the air. So that's where we get our relative humidity reduction. It then goes across the litter surface, removes the water, and then gets ventilated out of the shed. We'll talk about airspeed a little bit later, but evaporation rate is very closely related to airspeed at the surface. So we've measured the airspeed during side mode ventilation. And at the litter surface, the airspeed's quite low. It's zero. It's about 0.1 to 0.8 metres per second. We'll talk a little bit more about that in a few slides later. While we use side ventilation mode and while we know it's designed to get the litter dry, it assumes that a few things are happening. One, that you've got exhaust fans running to actually generate that air movement and that airspeed. The static pressure of the shed's got to be correct to get the right amount of airspeed to get that new air coming in up to the ceiling. The side vents have got to be adjusted correctly, which is about airspeed, but also air direction and getting that jet of air to go right, to half the width of the shed, and that there's no obstructions in the ceiling, which then interferes with the airflow. One of the downsides of this side ventilation mode for drying the litter is that you're pumping heat out of the shed. So you're creating heat with your heaters or the birds, and you're pumping that out to try and get the air moving. So where we say to get evaporation, you need airspeed, you need heat, you're actually reducing one, you're pumping out the heat to get the airspeed. Some heat exchangers have been around for a long time. I don't think we've seen too many of them in Australia. But there's more products coming on the market, and these things might be something worthwhile considering. If you're having trouble getting that air coming into the shed properly and getting it heated so that it can dry the litter out, installing these sort of units that blow the hot air that was in the shed over a heat exchanger to heat the air coming in, it saves energy. So you're actually trying to recover some of the heat energy that you've used. But it guarantees that the air coming into the shed is already pre-warmed and lower relative humidity. So if you're having issues in side vent mode, it might be worth having a look at some of these sort of products. Staying on side vent mode for a bit longer, when the fan turns off, airflow stops. So when the heaters start to run again, or the heat from the birds just rises to the ceilings and sits up in the roof apex. Some of that will be lost through the insulation through the ceiling. But the main point here is that you're not getting it to the floor. We need to get the heat down to the floor. The birds need it, the litter needs it. So whenever the fans stop working, you're not getting the heat where you need it. Another downside to this is that when the heaters start to run, they fill up the shed with heat from the roof down. So where are the sensors for your heaters? They're usually down near the birds. So the heaters run, they fill up the whole shed with heat until they make their way down to the sensors and turn off. And then the fans turn on and pump half of that heat out that you've just created before it's had a chance to do anything on the litter. It's not the best way to go about it. Once the fans sort of are turning on and turning off, because they cycle, particularly when the birds are really small, the airflow currents in the shed don't get fully formed. You don't get the airspeed across the floor like you need it for evaporation. The air kind of starts moving and then the fans turn off and it stops before it actually gets to make the full circle. Of course, the less the fans run, the worse this is, until the time when you've got the fans running constantly. But as fans are turning on and off, the airflow and the current in the shed is not really the right thing for evaporating water off the floor. What we need is to get airspeed in the shed to create turbulence and to get the air down through the birds and onto the floor so that we can actually remove the moisture from the litter. So I'm going to talk a little bit about circulation fans now. These aren't new. According to the survey that we did, I think it was about 20 or 25% of growers in Australia have already got circulation fans in their shed of some description. The idea is to continually mix and move the air in the shed so that it brings down that heat, brings it down to the floor where you need it. It'll also help to prevent cold from settling in pockets in the shed because you've always got air moving around the shed. And it helps to improve temperature uniformity in the shed, which is good for the birds, and it's also good for the floor and the litter. And we've spoken to a number of growers, and one common message that I hear is that when they installed circulation fans, it reduced their heating costs by 25 to 30%. So that could be the payback, for installing circulation fans and adding something extra into your shed. As energy costs are rising, this might be a way to actually reduce some of your operating costs, as well as getting a better environment for the birds, and as well as helping to dry the litter so you don't have to do as much in other ways to manage it. Stirring fans or circulation fans come in lots of different shapes, styles, and the way they're used. On the left of the screen, we've just got this normal sort of fan, which, if anyone's seen Mike Zarik's presentations going back 10 or 20 years, they were promoting these things a long time ago. For those who have been around a while, you'd remember the term of the racetrack, where you have fans going one way up one end of the shed, have them going the other way, and the idea is just to swirl the air constantly in the shed. The idea with that is not to create a lot of airspeed at the floor, but just to keep that air moving and to break up cold pockets and to destratify the air, mix the hot air back down from the ceiling back down to the floor. Other designs take the air more actively from the roof and blow it out sideways closer to the litter. Most of these are designed not to create a lot of airspeed or airflow, so they're good for improving the uniformity of the air in the shed, but they're not designed for evaporation. More recently, and this is featured in some of the previous webinars, is the higher capacity circulation fan system that has been sort of developed and researched in the University of Georgia. The idea with this system is to use slightly higher powered fans to actually create airspeed of up to 1 metre per second at the floor level continuously. So where I was saying earlier on that if you've got high relative humidity in your shed quite often and you find it hard to manage, by increasing the airspeed in your shed, you can actually counteract the effect of the high humidity by increasing the airspeed. So evaporation will go down a bit with the high humidity, but you can pick it up a bit with a bit more airspeed. The results from using this system in the US has shown that there's less wet litter. So areas of the floor, so under the drinkers that do usually get wet, the litter was drier and there was a lot less area affected by wet litter, and they had lower footpad dermatitis scores as well. They get good temperature uniformity throughout the shed, which is good for the birds, and there's no cold pockets or cold drafts. All their measurements have shown that it's not detrimental for growing chickens, and it brings more heat down to the floor. You're actually using the heat that's created and getting it down to the floor and transferring that heat into the litter and into the floor of the shed. So I've tried to draw some of what we're trying to achieve here with this system. The arrows show the air movement. So it sort of blows the air towards the end walls of the shed, comes back down and circulates back and goes back across the litter, and that's where you get your airspeed from. For sheds in Australia that have got ceiling baffles, of course, this isn't really going to work. I want to look at another way to try and blow the air sideways across the shed. So that's one of the things I'll be working on in the next 12 months or so. And hopefully it works out. I'd be interested to hear people's feedback or ideas on it. Just looking at the time, it looks like I've got a little bit more time. In a recent project, we looked at the effect of tilling on litter conditions, and we measured ammonia and odour as well, which I'm not going to talk about during this presentation. But one thing that we found was that litter tilling had an immediate effect of reducing moisture content in the shed, and that's a matter of mixing the wet areas with the dry areas. So I'll just talk about that first. So we looked at different areas of the shed. So we measured litter moisture content across, we call them transects, across the width of the shed. And then under the drinkers and in dry locations, we took grab samples. So we sort of try and cover the majority of the shed with these transects. We get like an average litter moisture content, but then we go targeting areas where we know that the litter is going to be wetter or drier. And what we found was that straight after tilling, there was an immediate reduction in moisture content of about 5%. Under the drinkers, it was a bit lower. So, I mean, the litter was even drier. There was a bigger difference. We reduced the moisture content by about 8%. And that's because you're mixing the dry litter at the bottom of the litter, because most of the water, particularly during the evening, sits on the surface. And also mixing in some of the dry litter from the sides as well. After 6 hours, and then the next day, we measured the litter again. And what we found was in the majority of the shed, that reduction in moisture content persisted. It stayed lower. And we think that's because of that, the higher evaporation rate in the afternoon following the litter tilling helped to actually remove more moisture from the floor, and we got dry litter as a result. In the wet areas, the moisture content picked up again, which is not really a surprise because we know that there's extra water going on in these areas. Under the drinkers, there's spilling from the drinkers. The birds might track there a little bit more often as well, and there's probably a little bit less evaporation for whatever reason. That's why they're wet areas to start with. So because they've increased, so by the next day, they'd actually increased again. The dry areas, a little bit different story to tell. I mean, the litter here was always dry. It was never, it's always drier than everywhere else in the shed. After tilling, the moisture content actually goes up, and that's because you're mixing a little bit of that wetter litter with the dry litter. But then by the next day, it had gone back down again. So these are areas where the evaporation rate is better in the shed, and probably less water going on. And so, yeah, it's not about getting, people talk about a shed, the litter moisture content in the shed. I see it in research papers all the time. The reality is it's not the whole shed that's wet or the whole shed that's dry. There are always wetter parts and drier parts, and it's about trying to manage the wetter parts in particular. That's most important. We also used, actually, one thing I'll talk about first, moisture content from in the under the drinker areas, as we showed, is always an issue because you've got more water going on in those areas. A grower down in Victoria came up with a way to try and get the litter out from underneath the drinkers, push it to the sides, and then they let the birds work the drier litter back in under the drinkers. And then this gives the litter an opportunity that was wet under the drinkers to dry in the drier areas beside the drinkers. It's an approach to go about it, and we'd be interested to hear if growers have got other ideas about how to actually get the wetter litter away from underneath the drinkers. We also scored the litter when we were doing this work with the litter tilling, using the method that was released a little while back with AgriFutures. We call it the litter guide, and there's a litter assessment process that you can follow in the litter guide. It's based around this table that we can see here. And what we collected was data, I guess, using these scores. And so the colours that you can see in each of these little sections of the information I'm going to show you here relates back to that table of the litter scores. So what we can see was that before tilling in the area under the drinkers, there was quite a bit of moist or wet caked litter. In the majority of the shed, there was only a little bit. In the dry areas, it was pretty much all dry and friable. The size of those circles is an indication of how much of it we saw. So it's the majority of the litter in those dry areas was already dry and friable. After tilling, all the cake litter was gone, which is what you'd expect. It's what you'd hope. If you didn't, then the tilling machine's not working very well. The moisture content itself didn't change all that much straight after tilling, which is to be expected because the litter was wet. The water just doesn't disappear. The water's still there. By the time we got to the next day or 6 hours later, what we could see was that the moisture content had actually started to dry. There was more dry litter in the shed than moist litter, or what we could describe as dry. Some of the cake reformed in some areas. Some of it was still a bit clumpy. When you took up a handful of it, it would still stick together. So it just takes more time. But by having tilled the litter and made it friable and released some of the water, what we ended up with, at least by the next day, was a lot less caked, a lot less moist litter, and more dry and friable litter. But I don't think this will be a surprise to anyone. I mean, this is why people are tilling litter. So just wrapping up, drying and preheating the litter in the shed before placing the chickens is one of the really important aspects of managing litter moisture content. If it starts wet, it's going to be really hard to manage because you'll have high relative humidity and it'll stay wet. Do whatever you can to reduce unnecessary water being added to the litter. And that might require reducing the pressure in your drinkers for a little while or considering changing to medium flow drinkers. And take steps to maximise evaporation from the litter, whether it be adding heat, increasing airspeed, adding circulation fans, bringing in or trying to keep the relative humidity in your shed low, so measuring it so that you can adjust it, and try and bring the moisture to the surface if the litter is wet all the way through. For tilling, all we'd really recommend is that till the litter in the mid to late morning so that you can get maximum amount of drying in the afternoon. But don't just till, increase the ventilation rate, do whatever you can, whatever you think you need to do that will drive more moisture out of the litter. Ventilate as hard and for as long as you can, based on the birds and the weather and all that sort of stuff, to try and get as much water out of that litter the afternoon after tilling, because that's when you've got a big opportunity to get the most amount of water out of it. But there will nearly always be wetter litter under the drinkers, so that will always need a bit of extra management. With the circulation fans, it's not going to suit everyone, but in some ways we can sort of probably think in a good, better, best kind of approach here. So air circulation just generated by your normal side vent mode ventilation is probably good. Having circulation fans that mix the air, get uniformity of temperature and humidity in the shed, but don't necessarily add airspeed to the floor, that's better. And from a point of evaporation and drying the litter, having an air circulation fan system that creates constant airspeed of up to a metre per second, especially early in the batch, is probably the best way to try and get the most amount of water out of the floor and reduce the occurrence of the wetter spots in the floor. Well, that's it for me today. Thank you very much for your time. For some more information, please get in contact with me. My details are there. I've also got a new researcher working with me. Her name's Beck. So I'm sure, and I know she's keen to get out and meet everyone and hear from you. So shout out to Beck, and hopefully we'll get you in touch with her pretty soon. Since the last time we did one of these workshops, webinars, there's some new videos that have been put up about the litter assessment process. So if you want one of the litter guides, please get in contact and we can post those out. But there's a video there about how it works. And much of the extension material too has now been moved away from the Extension Oz website and will be on the AgriFutures chicken meat website.